Welcome back to another lesson with Simkisa. Today we're going over the photoelectric effect. Now, let's talk about the photoelectric effect. What's happening here? Here is a metal. It's made out of these protons and nucleus, and then it has valence electrons all around. And those electrons are the ones that can be emitted. Emitted just means it comes out of the surface. It means here's the surface. Emitted, it means it's outside of the surface and it's here. Ejected means that it's bounced out and it's free to roam out into the world. Anyway, when a light is incident, a light of a suitable frequency is incident on this metal surface, electrons can be ejected, which is the main goal. That is the photoelectric effect. Now, we have a few things to discuss, like a work function. A work function, that is the minimum energy an electron needs to be emitted, which means this metal has a work function, let's say, of 5 joules. It needs 5 joules of energy in order to be emitted. For a different metal, it can be 6 joules, 7 joules, but it all depends on the metal. If it has a work function, it also has a threshold frequency. And the threshold frequency is the minimum frequency needed to emit an electron from a metal surface. Remember, frequency determines the energy. So all in all, it's like this thing has a work function, and it also has a threshold frequency. The minimum frequency needed to emit an electron and the maximum and the minimum energy needed to emit an electron. That light must have, in order for the electron to be emitted, which means come out of this thing, light must be higher than the threshold frequency. The light must have a frequency higher than the threshold frequency, and it must have a energy level higher than the work function of the metal. Now let's go to our calculations fast. This is the energy of the light. This is the work function, and this is EK max. EK max is the kinetic energy the electron will have after it's been ejected. If this thing is, let's say it has a work function of 5 joules, and the photon has 5 joules of 5 joules of energy. That's 5 joules equals 5 joules. 5 joules plus EK max. That's 5 minus 5, and EK max is 0, which means if the EK max is 0, it means this thing was not ejected. Yeah. And or if it's negative, it means that it was not ejected. But that's basically how you do it. There are other ways to write this thing where it's going to be HF, which this is a constant and this is the frequency. If you're given the frequency of the light, or you need to calculate frequency of the light, you can rewrite it like this because energy is equal to HF. And there's also a HC divided by, the cool part is H and C are both constants. So if you want the wavelength, you can totally, you don't have to do much because these two are constants. They're given to you on the answer sheet. So if you're since both of these are equal to energy, if you're given something the frequency of the light, you can find the wavelength. Or if you're given the wavelength, you can find the frequency. Or you can use either one to find the energy of the light. Always know that energy is associated with the light. Then we have the work function. The work function, it has its own equations. One sec. I can't pause this thing. I don't know why my phone doesn't allow that. Give me answer sheet. I'm still continuing. I can't pause the video. It won't let me. My phone doesn't have that setting. Manje lights. Okay, got it up. Anyway, Manje, what were we saying? Yes, we were talking about the equations. And for what reason? Anyway, so this thing is very important because most of the time you're going to be doing equations with this thing. And when it comes to this thing, you need to know that you can find any of these values using their other equations. You have to write this one first, yeah. And then afterwards, let's say you want to find the velocity and you have the energy, you have the work function, you can just insert this underneath instead of EK, but always write this one first. So you can find your threshold frequency of the metal, you can find your work function, you can find the velocity, the mass of electron. Don't get it twisted. One of the things they don't tell you is that they give you the mass of the electron. Here is the mass of the electron. This is what you use when it comes to this equation. Yeah, the one with EK max equals half MV. Yeah, you use that mass. Anyway, I think we've discussed my calculations. All in all, it's always just going to be maths, and it's nice, it's easy, but you just got to do some practice. Now let's move on to our graphs. No, let's move on to our circuits real quick. Okay, so here you're gonna have E circuits. What's gonna happen is this thing will be shaped as a curve so that over here when a light is emitted, they go straight here. That no matter where they go, they're going straight here, and then the electrons can absorb the light quicker. Once this is the cathode, this is the anode. By the way, this is where the this is the positive terminal. So the thing is gonna go so, and then this is the negative terminal. So this is the cathode, the positive side. Anyway, so Angeti, the light is going to go in there, the photons are going to be released, they're going to be absorbed by the cathode, and then they're going to be taken here all the way to that side. It's built like a regular battery. What we need to discuss is AMA effects. Okay, so so first we're going to talk about the brightness of the light. What is it? The brightness of the light is Angeti, when you shine a light, you're going to be shining it onto the metal. If your light is about this bright, it's only going to be hitting the surface area of the metal, and then electrons are gonna, Angiti photons are going to be released, and this, let's say 5 electrons are going to be emitted and ejected from the surface. If you have a brighter light, it's hitting a larger surface area, which means more electrons will be emitted and ejected. Kushuguti, brightness affects the number of electrons. That is going to increase. If there's an increase in brightness, the ammeter reading will increase, because the ammeter, it counts the number of electrons passing per second or per unit time. So this brightness is the only thing that's going to affect the ammeter. They ask this question every time. Wrong. Then we have E frequency. Each light has a frequency. Here's the order of the frequency. Don't mind the black. Starts off red. Sorry. One sec. The frequency goes higher and the wavelength gets smaller. So the red has the, how do I say that? It has the smallest frequency and longest wavelength. Wavelength and frequency are inversely proportional. The higher the frequency, the lower the wavelength. The lower the wavelength, the higher the frequency. So red has the longest wavelength and smallest frequency. Then it goes red, orange, yellow, green, blue. Don't forget indigo and violet too. You must remember that song because oftentimes they're going to ask you, Uguti, which one is going to have the high frequency, the green lights or the orange lights, or they'll ask something like that. When you must know the song and know Uguti, if it is going, which one is going to be low and high. They won't tell you which is higher and which is lower. You have to figure out a pippin. So here's the song: red and orange and green and blue. Don't forget indigo and violet too. Okay, so violet has the highest frequency and then it has the shortest wavelength because they're inversely proportional. So higher the frequency, lower the wavelength, lower the wavelength, higher the frequency. Yeah. Anyway, so if you change the frequency, which just means you're changing the light, it increases if you like change it from a red, because you got to remember red has the lowest frequency and longest wavelength. If you have, so just know energy is directly proportional to frequency. The higher the frequency, the higher the energy. So Ushubuti, if you change the frequency to a higher frequency, there's going to be a larger energy coming from the light. More energy means, and the work function remains constant. Kushubuti, there's going to be a larger EK max, which is the speed. So more energy, there'll be less energy gone because of the threshold frequency. Over here, let's say there are 20 joules and the threshold frequency was, let's say, 10, yeah. So 10 is the threshold, work function. Go show to the EK max is 10. Over here, there's 30 joules, and the work function is still 10. Go show to, hey, on my phone pause. Okay. Go show to the EK max is going to be now be 20. Because that's how it is. So because of the frequency, it increases the speed of the electrons. Speed is also EK max. Then we have a change in work function, which means you just change the metal. Let's say this is zinc, and let's say this is copper. Let's say this is gold. Yes. Okay, and manje, here's the energy coming from the light. 30 joules, 30 joules, 30 joules. Now, this one here, the work function is 30, which means the electron will remain here. Because here's the work function, and we're using this formula equals work function plus EK max. 30, 30, 30 minus 30, that's 0. So the thing was just emitted, it wasn't ejected. Over here, the energy was 30, the work function was 20. So Gushuti, the EK max is 10. Cool, this one already has the electrons will already have a greater speed. They've been emitted and ejected, and their EK max is 10. Then we have gold over here, which has a threshold frequency of 10. Over there, so it's 30 minus 10 is going to give us 20. So over here, the electrons will have a kinetic energy of 20. Then the speed of the electrons and the EK max will increase because of a change in the metal. So here are your three factors that are going to be affecting stuff. This one will increase the ammeter reading. These two will not increase the ammeter reading. They're just going to increase the speed of the electrons. Please ensure that when it gets that paper, everything goes mwah. Yo. Oh, by the way, this is the negative terminal because it has electrons, and this is the positive terminal because it does not have electrons. This one just has many electrons, and then henceforth it's going to go this way from the cathode to the anode. The cathode is shaped like a C, or it has a curved gasol. It's either built, doesn't matter how it's built, it's just going to be curved. This one's going to be straight. This is a vacuum. I remember they explained somewhere what a vacuum is. That's in Newbeg. No air particles within. Oh, it must be in a vacuum, so that inside, the reason they might ask you a question, Ruti, why is it that the anode and the cathode must be in a vacuum? This is to ensure that And it's a vacuum is where there are no other air particles. So it's to ensure that the photons and electrons, there's no collision with with dust particles or air particles, and the photons can just go straight to the cathode, and they don't have to be disturbed by these ama particles. So no outside particles will collide with the photons. That's why it must take place in a vacuum. This battery is just to ensure that direction, and store some of the energy. Oof, my chest. Maximum wavelength. Hold up, couldn't definitely bigger than that. Let's say they ask you what is the maximum wavelength of the photons. Maximum wavelength just means, so Angeti over here, this thing has a work function. That work function is going to come with a threshold frequency, okay? So Wushuruti, this thing, it says the threshold frequency is 50 hertz. No, 50 joules. And then the lowest amount of energy that can hit this thing is 50 joules. For there to be a photoelectric effect, there can only be 50 joules in order for this. That's the lowest it can get. Otherwise, there will be no photoelectric effect taking place. It can't be 49 joules, can't be 48 joules, must be 50 and above in order for there to be a photoelectric effect. Manjeke, this is going to come with a certain frequency. That is the threshold frequency, okay? And then it's going to be equal to the threshold frequency. That threshold frequency comes with a wavelength. This is the minimum frequency necessary to emit the electron. This is the minimum amount of energy necessary to emit the electron. This is the maximum wavelength needed to emit the electron. Because here, okay, let's say kono 30 joules la. No, yeah, and kono 50 joules la. It has a frequency, let's say asas got it has a frequency, and that frequency looks like this. Here, over here, from here, this point to this point is one wavelength. Let's say it is 2 meters of distance. This is the largest the wavelength can be ever. So this is the maximum wavelength. So if you have the threshold frequency, you can calculate the wavelength of that threshold frequency, because you're going to have 20, 30 or something, and then you're going to do my calculations. And then uzotola, we're using EHF, yeah. But then that's also because if you see it, 30 joules is going to be all like because that's the frequency that it has. It has a frequency of this. Look at the length of the wavelength of 30 joules. Look at how huge that is. We need some. This is the max. This is too large of a wavelength for it to emit anything. The most this wavelength can be is this, because higher 60 joules, which is going to do a photoelectric effect. It's going to be built like this. That is much smaller. So let's say this is 1 meter. 1 meter. So this is the maximum wavelength is 2 meters. If it gets any better, let's say it's 2.1 meters, there will be no photoelectric effect because the frequency went down. There's a wavelength and then there's a frequency. If the frequency is 2 like we want, if the wavelength is 2 meters, it's going to give us 50 hertz. Let's say it gives us 50 hertz. If it's 2.1, it's going to give us 49 hertz. And we don't want that. We want 50. 50 is associated with the wavelength of 2 meters. The higher up you go in frequency and in energy, the wavelength is only going to get smaller. And that is maximum energy. They took that out and then everyone was confused. All right, last section. Oh, no. I'm going to do one last video for E-spectrum because my voice hurts and I want to go drink some water. Anyway, So on the y-axis, we're going to have you're gonna have your EK max. Over here, you're going to have your frequency. Over here, what is it? There's gonna be your lines of like two different metals. One with the work function of 50. You're gonna write that on the graph, correct? That's minus 50. Here's the work function, and then the work function of 60. Manje, the frequency is increasing, it's increasing, and here's the threshold frequency. This is after angetsu when you have the threshold frequency, the EK max is 0. Oh, so over here you're gonna write down your work function. Over here it's the threshold frequency, and uzoqhubeka. Let's say magnesium point la. Oh, was in let's say, so like whenever some of the questions I'll ask, they'll just ask you what's the work function. If it's wherever it starts on this side, that's the work function, and you're gonna write it out as 5 joules because if young it's 50, the point is 0 comma minus 50. This is the work function. Then they're gonna ask you what is the work function when uzothi equals 50. You don't put the minus, it's not involved. The gradient of this thing is Planck's constant, by the way, h no h. And yeah, there's literally nothing else to discuss about the graph. The greater, it is directly proportional frequency, greater the frequency, greater the EK max. And yeah, I get the, like, I get those like, the only question they ask over here is like, where did I do a graph question? They always usually ama calculations. See, how will the value of it? Yeah. Maximum kinetic energy for P and Q. For this cathode is the neutron, the same set of axis as P. Today drained me. Is that my base? Oh, I lost my base. Sometimes I have one and sometimes I don't. Now replaced with another one. Let's see here. Let's see if we can quickly through some questions fast. The work function of a metal used in the cathode in a photo cell. Calculate the work function. From what I see here, we have threshold frequency, and that's all you need to calculate your work function. Global work function is equal to h, threshold frequency. The velocity of the photoelectrons emitted from the frequency of the incident light. The velocity, easy man. You're gonna do E equals wololo plus EK max E. Yeah, it's gonna be easy as 1, 2, 3. With the frequency of the incident line, easy. You're gonna put so frequency line to line. Wololo, we already calculated it, so that's the answer from La Pezulu Wololo. Then we have v squared. We're calculating the velocity, which means you make v subject of the formula. M uzothatha kwi-answer sheet, uzoyenza lento yakho, what is it? So hf minus wo half v squared divide by half divide by half then uzoshaya into zakho. The answer is going to be whatever this answer is. Let's call it x because I don't have time. It's going to be rooted there, and then you can get your answer. Yeah. Anyway, the maximum, I don't want this to go too long, but then I want to kind of like cover everything so that like it's just one 20-minute video. The photocell is now replaced with another one in which the function of the cathode is twice. Work function. Oh, the work function of the cathode is twice that of the metal in the first cell. So twice. What do we got here? We got 1, 2, 3, 4, 5. Okay. The work function is twice. So what do we calculate the work function to be? I don't know. Here's work function. Here's work function times 2. Here it is. Anyway, how will the maximum kinetic energy versus frequency graph? Oh, by the way, this is kinetic energy versus frequency. Just a little tip. The name of the graph is always the y versus the x. Anyway, The maximum frequency of G of this cathode is now drawn the same at whatever. How will the gradient of Q compare to that of P? The gradient of it's gonna be exactly the same. It will be, because remember I told you here, Guti, a gradient is always H. It's always Planck's constant. 3.1. Yeah, it's gonna be equal to, because it's gonna be exactly the same. The gradient is Planck's constant anyway. What will the value of the x-intercept of graph Q be? The value of the x-intercept. Oh, the work function. No, the threshold frequency. What is it? So angithi utholela ukuthi work function is 2 times the original, so you're going to use that as a fagwe equation yakho uthole threshold frequency, and that's going to be your threshold frequency. How? 8 times 10 to the power 14. Where did I get that answer? Habe. Manje ngithatha plans. Oh, because oh my gosh. So Angits is gonna be Ufola. Oh, don't forget when writing your answers, when they're gonna be like, what is the threshold frequency? Always look for this thing, because it's always Nala. Oh my gosh, the time things I get wrong. So like over here it's not 4, it's 4 times 10 to the power. It's 4 times 10 to the power minus 19. So you're gonna write there 4 times 10 to the power 19 joules. Nala. So over here, I get it 2 times. If 2 times everything, then 1, 2, 1, 2, 3, 4. You can get the memo of this paper. I don't know if I still have it. Anyway, so the reason I said 8 times 10 to the power bamban, because everything's just times 2. And it's the work function was 2 times the original work function. So more like maybe the threshold frequency is 2 times the original threshold frequency. Hey dog, I'm a little tired. I can't wait to be done with the paper. I hope it treats us kindly. Anyway, I think that's everything. I'm gonna do one more teeny tiny video on line emission, and yeah, then we're done.